Hello, and welcome to our third and final part of this day before the end of course exam review. I'm, of course, here with our good friend, Mr. Hayden. Hey, Mr. Hayden. What do you think of this class? Don't they look like a smart bunch? They wouldn't be frightened off like this tiny little scared baby? No. All right, so here's my suggestion. I know you guys probably hate me today. We will be working on math all day today, but the only reason we're doing this is to get you ready for the end of course exam tomorrow, which you guys are going to rock, and it's going to be great. So I wish you guys good luck on that, again, via video. But for right now, let's focus on what we need to focus on, and then I'm going to call this section polynomial stuff. Alright, so with polynomial stuff, we can talk about adding and subtracting polynomials. Now, we talked about all the other kinds of things with polynomials, like, the number of terms, the degree, all that kind of stuff. But when we're talking about, we're going to do adding, subtracting, multiplying, and dividing with polynomials. And if we're adding and subtracting polynomials, one thing to remember is that the exponents do not change. So when you're adding polynomials, the exponents do not change. It's only when you're multiplying do exponents change. Now, there's some tips on this screen, and might be a good idea if you're in algebra to take notes on this. It might help you. Okay, it might be something you want to look over right, tonight before the exam. So, Mr. Hayden, if they need some time to take out some paper, take out some pencil, whatever, hit pause. That's the beauty of this video. If there's something you didn't hear, something you didn't get, we can just rewind. So, key things to remember. When we're adding and subtracting polynomials, exponents don't change. It's only when you multiply do the exponents of the variables change. And if we're adding or subtracting, basically it's just combining like terms, meaning that they need to have the same variable to the same exponent. So in other words, x and y not like terms, x and a number are not like terms, x and x squared are not like terms. They would have to have the same variable and same exponent. Okay, here's our first example. So I have 4x squared plus 3x minus 9 plus 5x squared minus 10x minus 8. Why don't you try these two examples? Mr. Hayden will hit pause, and we'll go over them later. Pause. What do you think, Mr. Hayden? Did they get both of these right? We will see. Now, if I'm looking for like terms, I see them. I got some x squared, so 4x squared plus 5x squared, simply 9x squared. Remember, exponents don't change, so it's like 4 of these things and 5 of these things. Now, you may have also rewrote this to where the 4 and the 5 are underneath each other and then added down. That's okay. Sometimes that helps. Other thing to remember here is that we watch the signs. So I'm going to box in the signs in front of the number. I have positive 3x, negative 10x. Signs are not the same, so we subtract. We should get negative 7x or minus 7x. Another thing to keep in mind on this test, if you are not sure, use your calculator. That's what it's there for. Okay, and our third set of like terms, I see negative 9 plus negative 8. Signs are the same, so we're going to add them. And we get negative 17. So since none of these are like terms, because this has an x squared, this has an x, and this does not have anything, we need to stop. So you guys get that answer? How many people got that answer? If you got that answer, why don't you stand up in the air, spin around 3 times, just for fun of it. Okay, that looks good. I can tell. You guys are beautiful spinners, like ballerinas. Okay, so for the next example, we have a negative sign in the middle. So we're subtracting all of this from all of that. So what might be a good idea is do a little distributive property. And distribute that negative sign, making the opposite of everything behind it. So I'm going to rewrite these below wherever I see like terms. So this is going to be 3x squared minus 6x squared after we distribute. And the opposite of a negative makes this a positive, so I'm going to make this plus 4x. And now I'm just going to add down. So the answer that we should get, 3x squared minus 6x squared, would be negative 3x squared. Negative 2x plus 4x would give me plus 2x. And there's nothing here, so I'm just going to bring down my minus 2. And there's our answer. So that's how you add and subtract polynomials. As you can see, the notes up here are all we need to remember. Add like terms, the exponents don't change. Just integer rules after that. So what about multiplying and dividing? Well, before we had to find like terms, you couldn't add things that were unlike terms. But you can multiply things that are unlike terms. Basically, the rule is you just stick them together. Okay, and then the rule for multiplying, we are going to keep the base, add the exponents. Now that's not going to be the same thing for dividing. That's going to be subtract the exponents. Okay, that goes with this. Okay, but we're talking about multiplying, keep the base, add the exponents. Like this. This is 5x plus 2 times 3x minus 8. We are multiplying a binomial times a binomial. So what I want to hear from you guys is a bunch of distribution ninja. Hua, 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 hua. Okay? Give them a try. Just this first one. We'll hit pause and we'll talk about the second one in a second. To get the answers, here's how I did it. Hua, 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 hua. 5x times 3x is 15x squared. Remember, you can treat those like they're ones there, so if we keep the base, add the exponents, 1 plus 1 is 2. 5x times negative 8 is negative 40x. 2 times 3x is positive 6x. 2 times negative 8 is negative 16. Okay, we're not quite done because we have two like terms in the middle. So our final answer, 15x squared minus 34x minus 16. Did you get that answer? Good job. Give yourself a cheer. Well done. Alright, so now we are dividing. As you can see, this is all of this stuff divided by that. So the idea, keep the bases, subtract the exponents, but basically what we're doing is we're just splitting up this numerator by the denominator. So this is going to be divided here, here, and here. It's like three separate problems. So if I do 3 divided by 3 in our first term, that's going to give us 1. If I do x squared divided by x, we keep the base, subtract the exponents. So remember, we can treat this like a 1. Here as an exponent, the y also has a 1. So 2 minus 1 gives us x to the first. If we have y to the third over here, over y to the first, keep the base, subtract the exponents, that's going to give us y to the second. Okay, so we've done with our first two set of terms here. Now we go here. Okay, so what is negative 12 divided by 3? That is negative 4. X divided by x, keep the base, subtract the exponents, that's x to the 0 power. And y divided by y would be y to the 0 power, but we don't need to write all these things to the 0 power, so we are moving on. Now what we're doing is we're going to divide those. Alright, so 9 divided by 3 is just a positive 3. And then you notice there is no variables up here. So guess what? That just means the 3 is going to be divided by the two variables that we don't have, x over y. It's like we're just stating that it's being divided by that. The 9 and 3, we can combine. This we just leave like that. And guess what? That is our final answer. Did you get that? If you did, awesome. And this third topic that has to do with polynomials is factoring. Okay, factoring is kind of a big one. We worked a lot on that this year. Factoring, what you're trying to do is find what the terms have in common. I called it step 0 because before you do anything in these other ones, no matter how many terms, first find what they have in common. If they have something in common, you factor out the greatest common factor. You do that, find the greatest common factor between all your terms, and then just divide it by each term. If you have 3 terms, say trinomial, we can factor that with the x method. If you have 2 terms, you can factor that with the x method. Also, if you use 0 as a middle term, and if there's 4 terms, you can factor that by grouping. Okay, so we have some examples here. What I would like you to do is try these. I will go over these 1, 2, 3, 4, 5 examples. Okay, you guys work on them now. This is going to be a long pause. Although for me, it's not that long. For you, it's a long pause. All right, Mr. Hayden, hit pause. So, what'd you think? Did you get them all right? We will see. All right, so I'm looking at this example here. And I see there are 2 terms. Before we do anything, I have to find what they have in common. Do a step 0. So between 10 and 25, the greatest common factor there is 5. So I'm going to factor that out. Between b to the 4th and b to the 5th, greatest common factor is b to the 4th. The most I can take from both of them. I can take 4 from here, but I can't take and I can take 4 from here. I can take 5 from here, but I can't take 5 from there. Alright, so I'm going to factor those out by reverse, kind of like reverse distributive property. So the question is, 5 times what will give us 10? The answer is 2. B to the 4th times what will give us b to the 4th? Well, we don't even need anything extra to get that. But we do need to come up with a c. So let's carry that over. So this is 2c. Notice that if you distributed this, it would get exactly back to what we wanted. Okay, that's what factoring is. Now, minus 5 times what gives us 25? That's right, you get 5. B to the 4th times what? Give you b to the 5th. For multiplying, we keep the base, add the exponents. So we need an exponent of b to the 1st, because b to the 1st times b to the 5th, or times b to the 4th, will give us b to the 5th. And guess what? We are done. That first example, factored. Yes. Okay. Now about the second problem, that has two terms. Do they have anything common? No. So when it comes to step 0, we are done. But what you should notice is that this is a difference, subtracting, of 2 squares. So I'm going to use the x method for that one. I'm going to have to get some space for this. Okay, so 64x squared minus 25. Well, the factors of 64, I would say 8 and 8. Factors of x squared, x and x. Factors of 25, 5 and 5. Now if I multiply on the x, this is a 40x and 40x. How do I get these 2 numbers to be 0 for a middle term? Easy. So simple. Make 1 positive and 1 negative. Okay, so my answer to this is 8x. That is an 8, folks. Trust me. 8x minus 5. 8x plus 5. There. Okay. So 8x minus 5, 8x plus 5 are the factored form of that. Okay. Second one, or third one, that is a trinomial. Let's factor that trinomial. Let's factor it using the x method. So 8x squared. By the way, if you do step 0, do they all have something in common? No. Okay, so on this, we need factors of 18. There might be some erasing to do here, but I'm going to try 3x, 6x. I don't know. Maybe this will work. Maybe not. Let's see. Factors of 2, well, that's easy. There's only 2. So let's try 2 and 1. Multiply on the x. 6 times 2. And that's 12x. 3 times 1, 3x. Will those ever give us 15x? The answer is yes. You just have to add them, which means they're both positive, which means there's a plus here, plus here. Add your parentheses. We have our factors. So the answer is 3x plus 2 times quantity of 6x plus 1 and its factor. Okay, next one. I need to make some room. Okay, here we go. 2x squared minus 11x plus 5. X method. Trinomial. 0 step. Nothing in common. So I'm going to go 2x and x. I need to get this to be 11. So I'm going to put 5 here and a 1 there. Okay, x times 1 is 1x. 2x times 5 is 10x, not 5. Let's erase. That's the beauty of erasing. 5 times 2, 10x. Now, will 10x and 1x ever give me negative 11? The answer, of course, is yes, if they are both negative. So negative 1 plus negative 10 gives you negative 11. That's what we wanted. So our answer to this one is 2x minus 1 times x minus 5. X method. Factoring. All right. Now this one, it's got 4 terms. What do we have to do? Factor by grouping. So I'm going to group these two together. What do 2x, I'm going to write it here. No, I'm not. Now I am. What do 2x squared and negative 6 have in common? Negative 6x have in common. Well, for one, they have 2. For another thing, they have x. So I'm going to divide both of these terms here by 2x. Okay, 2 divided by 2 gives me 1. X squared divided by x is 1x. 2 divided by 6 is 3. X divided by x is 0 power. We don't need it. Alright, halfway done. So now I'm going to do factor this x, y plus 3y. What do they have in common? Well, I'm going to drop this negative sign here. And I see that they have a y in common. So I'm going to factor that out. Which means I'm going to divide both of these by y. So xy divided by y is just x. And, oops, made a mistake. Keep in mind that we do have a negative right here. So negative went here, but when we divide 3y by negative 3y, it's going to be negative. But you probably should have known that, because remember, we need these two to match. 1x, x minus 3, they're going to match. Because when these two match, we just kind of group them together. And the way we group them together, 2x minus y, it's like 2. We treat these like coefficients. So say I have 2 apples minus y apples. I would simply have 2x minus y apples. And thus, I have factored that by grouping. Did you get that one right? Congratulations. And we have come to the end of our video. Thank you, Mr. Hayden. Look at this little boy. I bet you have never enjoyed peanut butter as much as this little kid just enjoyed that peanut butter. I would not want to clean up after that. But good luck on your end of course exam. I know you guys are going to do it. And of course, Miss Arbelize started this. We're going to end this video with a math joke. Now, what do mermaid mathematicians wear? Obviously, they wear algae bras. What? Thank you, Mr. Hayden. Enjoy. Good luck on the end of course exam.